Welcome to this deep dive. Today, we're digging into the recent Q1 2025 earnings call from Vertical Aerospace.
Yeah, the plan is to really walk you through the key bits from that call. We'll look at the financials, their progress on getting the VX4 aircraft actually flying and certified.
Right.
And also unpack some, pretty interesting strategic moves, especially around their battery tech and the new hybrid program they announced.
Okay, sounds good. Let's start with the money side then. Q1 2025 financials, what did they report?
Okay, so the main number for cash flow, the net cash they used in operating activities for the quarter, that came in at roughly $30 million.
$30 million. And did they give any update on what they expect to spend for the whole year, or is that the same?
No change there.
Yeah.
The full year 2025 guidance for cash spend, it's still pegged at approximately $110 million to $125 million.
Okay.
And they finished the quarter with about $90 million in cash and cash equivalents sitting on the balance sheet.
Right. There was also a really big number mentioned, a non-cash item that hit their profit and loss statement. Can you break that down simply?
Yes. That was a pretty eye-watering $396 million non-cash credit to the P&L in Q1.
A credit?
Yeah, a credit. It's linked to the accounting treatment for changes in the value of some financial instruments they have, specifically these convertible loan notes.
So not actual cash moving around.
Exactly. It's really important to get this. It's purely an accounting thing. It doesn't mean cash came in or went out. It fluctuates a lot and doesn't affect their actual cash position or their burn rate.
Yep.
Think of it as paper accounting.
Got it. Paper counting, not real cash.
Right.
Okay, moving on from the financials then. They spent a lot of time talking about their Flight Path 2030 strategy and, progress towards getting the VX4 certified. What's the latest there?
Right. Flight Path 2030, that's their big strategic plan, their roadmap to, they hope, lead the EVTL market by the end of the decade. They really stress they're making good progress against the metrics and the certification timeline they laid out.
And specifically on a flight testing side, what's been happening?
Well, they've built on the thrust-borne testing they did earlier. A really key recent step was conducting these record-breaking piloted high-speed taxi tests with the VX4 demonstrator.
High-speed taxi test, why is that so significant?
Because it validates key systems like the landing gear, brakes, and control responses under real-world loads and speeds on the ground. It's a critical precursor to actually getting airborne safely.
Okay, so what's the very next sort of big hurdle or milestone we should be looking out for?
The next really big one is piloted wing-borne flight. So flying horizontally using the wings for lift. They expect that to kick off in Q2 2025.
So soon then?
Yeah, very soon. And this is, it's a major step. It puts them in, the top couple of companies doing piloted flight tests. And importantly, these tests will happen in public airspace.
Public airspace, with the regulator involved.
Exactly, with the UK Civil Aviation Authority, the CAA, directly overseeing it.
That sounds like a big deal. How does that approval process work with the UK CAA? Is it different?
It is quite rigorous. The UK system involves joint liability between the company and the regulator. So each phase of testing needs specific, explicit CAA approval.
Right.
For this wing-borne flight permit extension, they actually submitted something like 20,000 pages of documentation.
20,000 pages. Wow.
Yeah, so getting that green light from the CAA, it's a really strong signal of confidence in the aircraft's safety, its design, and its readiness to fly in public.
Okay. Now, there was some chatter recently, wasn't there, about the UK CAA potentially changing its standards, maybe aligning more with the FAA, which some interpreted as maybe a lower safety bar. How did Vertical address that?
They tackled that directly. They said they talked to the CAA, their home regulator, very frequently. And following those recent claims, they actually got written confirmation from CAA management.
And what did that confirmation say?
It stated unequivocally that the Polish standard for these types of aircraft remains SC VTOL, and the safety requirement is that 10 to the -9 probability of catastrophic failure per flight hour.
Which is the same as commercial airliners.
Exactly the same ultra-high standard. So based on that written confirmation, no change to the fundamental safety target in the UK.
Okay, so what about harmonization then?
Well, they did acknowledge the CAA is working hard on international harmonization with the EASA and the FAA. That's crucial, obviously, for global operations. But they emphasized this harmonization isn't happening at the expense of safety.
Right.
Their core belief, which they say their customers share, is that passengers will demand airliner levels of safety. For them, safety is just non-negotiable.
And sticking to that higher 10 to 9 standard, how do they see that positioning them globally?
They're pretty confident that certifying to this highest global standard will be a key advantage. It means their aircraft, designed for passengers, should be able to operate in any jurisdiction worldwide without major regulatory hurdles related to safety levels.
They also really emphasize the importance of having experienced test pilots actually flying the plane, not just relying on digital data. Why is that still so critical?
Yeah, they did stress that. While the digital twin and simulation data are vital, having, highly experienced test pilots physically flying the aircraft in real conditions gives indispensable qualitative feedback.
Like the feel of the aircraft.
Exactly. How it handles the workload, the comfort. These pilots provide insights you just can't get from sensors alone. It's about refining the whole operational package to meet what customers actually need and expect beyond just meeting the specs on paper.
And overall, are they still on track for their big 2025 goals? Like completing the main flight test phases?
Yes, they reiterated they're on track to complete all phases of the piloted flight test program by the end of this year. That includes the big one, achieving full transition flight.
Going from vertical lift to wing-borne flight and back again.
Precisely. Nailing that complex maneuver by year-end keeps them confident about their overall certification timeline, targeting 2028.
And I think they mentioned boosting their flight test capacity as well.
That's right. They're effectively doubling their airborne test fleet capability this year. They're finishing assembly of an identical twin prototype.
Ah, a second aircraft.
Yeah, it's already at their flight test center.
Yeah.
This will obviously help speed up the standard flight testing, but crucially, it's also earmarked for installing and testing that new hybrid powertrain they announced later this year, so they can run things in parallel.
Okay, that hybrid mention is a good segue. Let's talk about strategic partnerships and sort of wider industry stuff like infrastructure. What were the updates there?
They reported good progress on partnerships. A really major one was formalizing and expanding their relationship with Honeywell.
Honeywell, what exactly are they supplying for the VX4?
Honeywell's providing some really core systems for the certification and production aircraft. We're talking the flight controls, basically the aircraft's brain and nervous system, and the overall aircraft management systems.
Okay, critical stuff.
Yeah. And they also picked Honeywell for their Anceptors, which are essentially pilot assistance software tools designed to make flying easier and safer. They see Honeywell as key to getting the VX4 built efficiently and reliably.
And the value of that Honeywell deal?
It's substantial. They mentioned approximately $1 billion over the next 10 years.
Wow. Okay. Beyond specific partners, they also talked about industry-wide needs, like charging standards.
Absolutely. They made a point of announcing they're adopting the Combined Charging Standard, CCS, for the VX4.
CCS, that's the same one used by who else?
Yeah, same as folks like Beta Technologies and Archer are adopting.
Yeah.
Their reasoning is pretty straightforward.
Yeah.
Having one common standard is vital for the whole industry.
Makes sense.
It simplifies things for manufacturers, for operators, for the companies building the charging networks. Ultimately, it should lower costs and just speed up the adoption of electric aviation generally.
And for an airline or operator actually using the VX4 day-to-day, what's the practical win with CCS?
Quick turnarounds. CCS allows for fast charging, including battery conditioning, which is essential if you want to run, say, frequent shuttle services. And using a common standard means their aircraft can plug into any compatible CCS charger right away, like Beta's network, for example. Interoperability from day one.
Got it. They also mentioned changes to their board, strengthening the leadership team.
Yes, 3 new directors joined the board: Chris Haber, J.K. Brown, and Karen Stenderad. And that follows other changes earlier in the year, like a new chairman and a board advisor.
So what kind of expertise are these new people bringing? Why bring them on now?
It looks like a very deliberate move to bolster their governance and strategic leadership as they get closer to, the really challenging phases of certification and scaling up production.
Okay.
The new directors bring deep experience that complements the existing board. They specifically highlighted expertise in industrial scale-up and, importantly, capital markets.
Like fundraising?
Potentially, yes. You've got Chris Haber with COO experience at major investment firms, J.K. Brown as a founding partner with capital markets background, and Karen Stenderad bringing sustainable investing and board advisory experience. It really seems geared towards navigating that next phase of industrialization and financing.
All right. Now, for what felt like a really central part of the call, their whole battery system development story, which led into announcing this new long-range hybrid program, Who presented this section?
That was led by Dr. Limhi Somerville, their director of engineering. His background is super relevant, been at Vertical 6 years, leading powertrain and battery work, came from Jaguar Land Rover, Argonne National Lab.
Okay, automotive and research background.
Exactly. And crucially, he also chaired a key Euro K electrical standards group for 5 years, so he helped write some of the certification rules EASA actually uses. He knows the tech and the regulations inside out.
And he really positioned the battery as the heart of the aircraft. What did he highlight about its capabilities?
Yeah, he called it the cornerstone.
Yeah.
He talked about their team having this mix of aerospace, automotive, and electronics know-how. Performance-wise, he mentioned a 4-to-1 cell-to-pack ratio. Meaning for every 4 battery cells, you only need 1 unit of structure, cooling, electronics, etc. It's a measure of how efficiently they package the cells. Pretty good. And he stated they get over 200 watt-hours per kilogram energy and power density.
Which is key for range and power.
Absolutely.
Yeah.
More energy, less weight. For durability, they're seeing over 800 full charge discharge cycles while keeping around 90% of the battery's original capacity.
It seems pretty robust for aviation use.
And he talked about cost efficiency, linking it to this razor blade model.
Right. So the idea is like printers and ink. The battery system is consumable. It'll need replacing periodically, maybe once or twice a year, depending on usage.
Their system is designed so replacing the cells is relatively low cost. This creates a recurring revenue stream from battery replacements, and they expect this to be high margin, over 40%. Over time, they see this becoming a really significant part of their revenue, maybe even reaching a 50-50 split with aircraft sales in the 2030s.
Interesting model.
And he also mentioned potential second life uses for old batteries, maybe marine power, grid storage as extra possible revenue, but that's not baked into their main plan yet.
What about fast charging and cooling? And how does all this battery work actually help them get certified?
Well, the fast charging and cooling are optimized based on extensive rig testing, vital for those quick turnarounds we talked about. But the certification link is critical. Dr. Somerville stressed the battery was designed from the very start to meet those super tough EASA and CAA SEVTL safety rules that 10 to the -9 standard again.
Right, the airliner standard.
Yes.
Yes.
They developed their own proprietary battery management system, or BMS, to the highest safety assurance level with sensor redundancy, optimized software, all stuff you need for that level of certification.
He mentioned they're on, their 8th battery design and using the 11th prototype in flight tests. How does iterating like that help prove safety?
It's fundamental. That constant cycle of design, build, test, learn, and improve is how you demonstrate you meet those incredibly demanding safety standards. He gave an example. Their latest design is over 100 kilograms lighter than early prototypes. That's like 10% mass saving.
Which is huge for performance.
Exactly. But crucially, they achieve that while also improving safety and capability. It's not a trade-off. This refinement through iteration is how you hit that sweet spot of performance and certifiable safety.
And they highlighted some specific, quite dramatic sounding safety tests, drop tests, and thermal runaway.
Yeah, these are non-negotiable for aviation batteries. They've been doing drop tests since 2020. The latest was April 9th. They passed a 15.2 meter drop test with a full battery pack. He compared it to helicopter fuel tank tests.
Yeah.
But the key thing he stressed wasn't just passing the drop. It was passing it while the battery remained fully functional afterwards. Apparently, that's extremely tough to achieve at their energy density, a big safety validation.
And the thermal runaway tests, those sound serious.
They are. They've done almost 200 tests on different battery versions. The latest, April 29th, was passing a full-scale test on a sub-pack from the actual VX4 design. These tests simulate what happens if one cell catastrophically fails and catches fire.
And the goal is to stop it spreading.
Precisely. The design has to prevent that fire from propagating to other cells or escaping the battery enclosure. It's all about containment.
So if the worst happened and a battery fire did start mid-flight, what's the safety implication of passing these tests?
It ties directly back to that 10 to 9 safety requirement. It means the aircraft is designed so that even in that incredibly unlikely event, the fire is contained. The crew can continue to fly safely, maintain full control, and land the aircraft normally or at an alternate airport. The occupants are safe. The aircraft structure is safe. This capability is absolutely fundamental for meeting SEVTL certification. They sounded very confident that their testing and design approach proves they can meet these requirements.
And off the back of all this battery work, they actually announced they're open for business to sell these battery systems to others.
Yes, that was quite a significant announcement. They're now ready to offer their battery tech externally. Apparently, they'd turned down opportunities before to stay focused internally.
So a potential new revenue stream.
Could be.
Yeah.
It shows real confidence in the tech and their team's ability to support it for other applications, beyond just their own planes.
Which brings us neatly to the other major announcement, this hybrid program. What's the story here?
So this has been bubbling away internally for about 18 months. It follows their pattern. Develop quietly, prove the tech, then talk about it.
Okay. And the concept?
Essentially, they're adding a power generator, likely a turbine, to the electric aircraft. It uses a segregated electrical system for redundancy, aiming for category-enhanced compliance, meaning it can handle major system failures safely.
And how would it operate? Still electric takeoff and landing?
Yes, that's the idea. All electric vertical takeoff and landing, keeping things quiet in urban areas. Then, during cruise flight, the turbine kicks in, generates power, charges the batteries, and massively extends the range. Then shut down the turbine for a quiet electric landing.
You said massively extends the range. What kind of numbers are we talking?
Pretty dramatic increases. They mentioned potential for ranges over 1,000 miles and payloads exceeding 1,100 kilograms.
Wow, okay. That's a completely different mission profile than short urban hop.
Exactly, and that's the point. This unlocks totally new markets for them, which they see as additional upside beyond their core Flight Path 2030 urban mobility targets.
Like what kind of markets?
They specifically called out defense, cargo, emergency medical services, and longer-range commercial routes. They argue their larger airframe is uniquely suited to carrying meaningful payloads people, or cargo, over these much longer distances compared to smaller EVTLs.
And how does this hybrid system actually fit into their aircraft development plan? Are they building a whole new plane?
No, that's key. It integrates into their next-gen VX4 variant, which is their third prototype aircraft. Flight testing for this hybrid version is planned for 2026, so it fits within their Flight Path 2030 timeline.
And the power source?
Their first hybrid work used a combustion engine, kind of proof of concept. The one they're developing now for the flying prototype will use a gas turbine generator.
Dr. Somerville mentioned something about the technical challenge of having one engine power multiple independent electric systems.
Yes, he highlighted that. Proving that a single generator can safely power multiple electrically separate propulsion systems, especially under tricky failure scenarios, is apparently one of the most complex engineering challenges. It's crucial for getting that category-enhanced type certificate needed for flying over populated areas reliably.
And why does having a larger airframe help them integrate this hybrid system more easily than maybe some competitors?
This is a point they really pushed. They say they can fit the hybrid powertrain mostly in the existing luggage compartment space.
Ah, okay.
There's only a minor impact on cabin space in a piloted version. This is a huge advantage because it means they likely avoid needing a completely new type certificate, saving massive time and money, and it doesn't kill the passenger carrying ability.
Right.
And for unpiloted versions like cargo or defense, there'd be no impact on the available volume at all.
Okay, let's connect all this tech back to the market. What did they say about their customers? How are these developments being received?
They emphasize their strong existing order book.
Mm-hmm.
You know, American Airlines, Bristow, Babcock, JAL, GOL, big names globally.
Yeah.
And they explicitly linked holding on to this global customer base to their commitment to that high 10-to-9 safety standard.
Yeah.
Clearly, that's table stakes for these serious operators.
How do they actually work with these customers? Is it just taking orders?
No. They described a really engaged process, working closely with them from the start, listening to what they need. They bring customers over to Bristol twice a year for multi-day visits. Customers get to see the plane evolving, meet the engineers, really dig into how they'll use the aircraft, the deployment models. They feel this collaboration is why customers picked them.
And what specific capability do customers apparently value most?
The airframe itself, specifically its ability to carry not just passengers, but also a decent amount of luggage. They mentioned launching with 4 passengers plus 130 kilos of luggage allowance.
Which is quite a bit.
Yeah, and the ability to potentially expand that to 6 passengers within the same certified airframe relatively easily. They claim that combination is unmatched right now.
And they're planning to open the order book again?
Yes, sometime this year. Now that they're closer to certification with a firm 2028 target for the electric VX4, they want to deepen those existing relationships and expand their global customer base.
There was a question about a UK airline looking elsewhere. How did they respond?
They kept it general, just reiterated they're opening the book globally and talking to potential customers everywhere.
Going back to the battery for a second, they tackled that perception of a trade-off between safety and performance head-on, didn't they?
They did, very firmly. They rejected the idea it's an either situation.
Yeah.
Safety, they repeated, is paramount, non-negotiable, aiming for that 10-to-9 standard. But they argued achieving high performance, like the 200 Wish/gram density, isn't done by sacrificing safety. It's achieved while also improving safety.
Right.
Better materials, smarter design these things can make the battery lighter, more powerful, and inherently safer against things like thermal runaway. The goal is both simultaneously.
Got it. And just quickly, any updates on the actual electric power units, the EPUs that spin the rotors?
Just that the current ones on the test aircraft are performing really well, even better than expected. They mentioned having a few options for suppliers for the final certification and production contracts, but nothing concrete to announce yet on who that might be.
Okay, so if we pull it all together, what are the main takeaways from this Q1 call?
Well, it feels like tangible progress. Flight testing is right on the cusp of wing-borne flight. They seem to have strong backing from the regulator with that public airspace approval. Key partnerships like Honeywell are locked in. The board looks strengthened for the next phase.
And the big reveals.
And yeah, the big reveals. Showing off their advanced battery capabilities backed by some serious testing data and launching that hybrid program, which could open up completely new, longer-range markets like defense and cargo. All while apparently keeping their spending on track. They certainly sound confident about hitting that 2028 certification for the electric VX4.
Okay, so here's something to think about based on everything we've just discussed. We heard vertical strategy. Certify the electric VX4 to the absolute highest safety standard for cities, while also developing this long-range, high-payload hybrid version for different missions. Does this signal that the future air mobility market might actually split into distinct tiers?
That's a great question.
Could we see, one tier of super safe short-range electric vehicles, mainly for urban air taxis, and another tier of perhaps different standard, higher capability hybrids focused on logistics, defense, longer routes? Or will things like regulatory harmonization and customer demands eventually force everyone towards a single high safety standard, no matter the powertrain or mission? How will companies pursuing these different paths navigate that landscape? Something to mull over.
Definitely food for thought.
Thank you for joining us for this deep dive into the Vertical Aerospace Q1 2025 earnings call.